And what has to be true about the probability of the union of those subsets? That's the third axiom. It's a hard one. Nobody ever talks, hardly anybody ever talks about it. It's the probability of the union of all those subsets is equal to the sum of the probabilities of the union of subsets. No, I just said what the axiom was. You know. So the probability of the union of all those subsets is the sum of probabilities of the individual subsets. So that's critical. And that becomes important later on when we prove central limit theorems and things like that. Okay, so you did pretty good. You got two of them, the third one is somewhat hard. She's young. Laura.
I had a question about that element.
Yes.
So if I'm just picturing like a chart with all of my sort of outcomes on one spot.
Uh-huh.
The probability of the union of them all happening, they can't all happen at the same time.
No, I didn't say that. When we talk about the union of A and B, it's A or B. So the idea is that the sample space of the two-coin experiment is head-head, head-tail, tail-head, tail-tail. That's the whole sample space. A subset of that sample space is head-head, head-tail. Isn't that a subset of the sample space? Another subset is head-head, tail-head. Another one is isn't that a subset of the sample space? Just head-head. So now list all the possible subsets of that sample space that you could ever, that anybody could think of, and call that A. And so, for example, this one is, that's A1, that's A2, that's A3, and you've got a whole bunch more all the way out to A sub n. Okay. It takes a long time to do it, even with such a small sample space. It would take us a while to figure out all the possible subsets of that sample space, right? So what I just told you was that the third axiom is that the probability of the union of all the AI from I equal 1 to n is the probability that in the outcome of our experiment of tossing 2 coins, you get any one of the subsets. So if I take my 2 coins and throw it up in the air, the probability that my outcome falls in A3 is a quarter. The probability that my outcome falls in here is a half, and so on and so forth. And then you got to remember that we have to subtract off all the intersections.